will be the flat surfaces, and the vertices will be where the edges meet, hence the corner. And then the edges will be where the faces meet. And you can call it a line, a segment. So let's start counting them for example number 1. If I give you a rectangular prism, how many faces can we count? We have the right, the left, top and the bottom, front and back, 6. For the vertices, I think I want to actually put in the points. Here's 1, 2, 3, 4. Is that it? 5, 6, 7, and 8. My edges. How many edges should there be? 12, because there's 4 on the top, 4 on the bottom, and 4 to connect them, right? So we have 12. Okay, let's try example 2 and 4 with a partner. 2 and 4.
Let me think.
If you kind of physically motion the flat surfaces, it kind of helps.
Taking pictures for me.
15 of the E10.
There's 2 sides on this one here. And there'd be side here, side here, side here, side here.
Someone saw a pattern? There's a formula.
I
Very
knew it.
good.
A something, something, something.
I think there's a pattern.
All right, go on to number 4. So for number 2, we have 8 faces, 12 vertices, and 18 edges. Reese, did you toss something across the room? I think I saw it. Pick it up later. Okay? Pick it up later.
6 faces.
See, yes. Okay, number 4 is kind of unique.
Oh, I was doing 3.
Oh, no.
Hooray! Yippee!
How many faces do I have in the example number 4? 6? Oh, yeah.
Oh boy. This ain't that good though.
In my opinion, I think the vertices are the easiest because you can actually put a dot on it. Did anyone find how many vertices? 6? Oh no.
5.
6. Good job. You're like, I knew I can count. For the edges, I will kind of go over each side.
9.
A little bit more.
10.
10.
12. I got 10.
All right. So there's actually a pattern. If you notice a pattern, maybe you could be a mathematician, right?
Dude, I noticed.
So we have this theorem. Any idea how we can pronounce this? Something theorem? It looks like Euler's, right? But it's actually Euler's. It's weird. But I'm going to say Euler's because it looks like it. The formula basically states the following. I'm going to actually look at this one right here. No, let's look at the one that's more common. If I were to take this and plug in the formula, it'll always be true. So if I take my faces, which was 6, and the vertices that we counted was 8, will always be equal to 2 more than the edges. Is that actually true? Yeah. So let's say I know 2 parts, and you're missing maybe an edge. Could we use this formula? You can. But I'll never look at it after today. Okay? All right, let's start naming our figures. Number 5. It is a prism, correct? What kind of prism? Triangular. Now it's triangular because of the following. Your bases are always congruent and they're parallel to each other. So your bases pretty much control the naming of it. So if I were to show you this picture right here, my base are identical and they're also parallel. Do we see that? So here I have it. Also on your Pearson, and if you were to even look at a textbook, it'll also tell you this is a right triangular prism. And you'll see why from part B. What happened to part B? I took the prism in, angled it, right? That's called an oblique. So if it looks normal, you just say right. If it looks kind of like squished to the right or left, it's going to be oblique. Let's highlight the base. What shape is this base right here?
Rectangular prism.
Octangular. It's not 8-sided. How many sided? 6. So it's
Tectonic prism.
hectonic.
Oh, I was close.
Hexagonal, or really you should, it's pronounced as hexagonal.
What's the?
I'm gonna say hexagonal. Sounds a little normal for me. Okay, so looking at C and D, which one is going to be right and which one is going to be oblique? D is going to be oblique. So let's write on here. We have oblique. What kind of shape is this called? Cone. And then here I have a right cone. Yeah. For the cocaine on E, let's assume the little curvature is not on there. What kind of shape would that be?
Cola.
It'll be a cola?
Cylinder.
What kind? Right or oblique? Right.
Coca-Cola.
George, you're being silly today. That's true.
You're on dude.
You also talking.
Bro, you're cut.
All right,
No, don't get me. Don't get me.
let's go on to the back. Y'all, I'm recording. Be nice. Oh my. Okay, let's underline the following. The following is polyhedron, and the one underneath the next one are not polyhedron. So let's discuss with the neighbor. What makes a polyhedron? And on the right side, what makes it not? Talk to your neighbor.
I was thinking because it's sharper. The polyhedron's so rounded. Okay. You mean the non-polyhedrons? Does this have a lot to do
All right, Shayna, give me one feature of a polyhedron.
Polyhedron has
All straight lines? Okay, very good. John, give me another feature of a polyhedron.
They have like sharp edges.
Sharp edges, okay. Give me another one, Abby.
when each edge ends in a point.
It ends in a point. I think that's what John basically said. Okay? So just by looking at this, I'm not going to define it. Polyhedron, not a polyhedron. Basically, don't give me any curves. Okay? So let's look at the convex polyhedron. And I know most of you guys say something about pointing out. When something is convex, that means all vertices. Every single one of them. Oh, I can't spell. Vertices. Is that how you spell vertices? Are
Oh, there's another
Point.
I after.
It's English class. So, and I'm
I.
C, yeah,
That's
I, yeah.
Really? Oh my.
That's not right.
Hey, that's okay. I can't spell.
Someone thinks there's.
I feel like it should just be ES, not IES.
Yeah, I don't think it is.
I'm gonna go with my gut. But you could be right though, right? So on the next one, let's go ahead and underline convex polyhedron and not a convex polyhedron. Are all the vertices actually pointing outward on the left? Every single one of them? On the right, Every single one of them pointing outward, or some of them? Some of them. An example will be, this is not pointing outward.
Yeah, that thing going in.
And this one, that's right. Now, we talked about prism already. So let's go ahead and actually define this. Prism is a polyhedron with two congruent and parallel bases. Again, that was discussed on the first page. It is a polyhedron with two congruent and parallel bases. So do I have a polyhedron right here? It is a solid.
No,
It's just a solid, okay? Is this a polyhedron? Yes, it is. Is this a polyhedron?
No.
It is a solid.
Oh.
All right, moving on to pyramid.
I swear that looked like a circle.
For the pyramid, we have two conditions. It is a polyhedron with the following conditions. The base must be a polygon. And the lateral faces that lean must be triangles with a common vertex. And I'll show you some of them if I have more than one. Yep. What shape is my base for this pyramid? So we have a triangular pyramid. Are the sides really identical?
Yes.
Triangle coming to a common vertex? Okay, on this one, I have a square pyramid, hence just the pyramid, right? And the sides are triangles that come to a common point. Good?
Sure.
All right, let's go on to a net. Can someone define a net? Not in a fancy way. What is a net?
Oh, it's like when you put it all together, it makes a 3D thing.
Okay, the way I see the net basically is, I would say you guys are all wearing nets. And you're like, what? Let's all write out, it is an outfit of a solid. It is an outfit of a solid. So I'm gonna give you one of them. It is an outfit of a solid. Sounds kind of cute. I like your net. Your net is on point. Here's my net. What shape or what solid would create?
Circle.
Circle? I see a
A
circle.
cylindrical prism.
Cylindrical prism.
Oh.
So here I have
See,
a
that just
cone.
doesn't, no, I like mine.
You like yours better? Okay. So let's write on here the following. Here I have a cone. What about B? Cylinder. Cylinder. Is it ER? ER. What about C?
Triangle.
Triangular prism.
Square.
And then we have a cube.
Oh.
Where to the actually go?
Yes, ma'am? How is C not a pyramid? Pyramid is understood as a square base. But anything else would be called with the new bases. So could there be hexagonal pyramid maybe? Really hard to draw, but I'm not gonna bother. All right, let's go on to the back. Put a big star, big star. Okay, on number 10, I want you to box cross section. So let's say I have a cone and I cut horizontally on the very, very tip of the cone. That's going to create a dot. So here I'm gonna have a dot. Oh, speaking of, look at that. Almost hexagonal. What kind of cone is that called? Not cone, pyramid. Pentagonal? Okay. So if I were to take a knife and cut it straight through horizontally, let's see what that would look like on a flat image. It's gonna create another regular pentagon. Notice my figure is not very pretty, so I'm gonna write on here it's a regular pentagon. Okay, part C. What is that shape called? Hexagonal what? Is it pyramid? Prism. Prism. So if I cut it vertically this time, what shape am I going to get? Hexagon? And hexagon I can draw, I think. Boom, boom, connect. The boy's talking over me, please stop. I'll be done pretty soon. So let's write on here, we have a regular hexagon. Part D looks kind of unique. If I cut straight vertically through a cone, what shape is it going to create? Specifically, what kind?
A circle. There should be a circle.
So if I were to look at a cone, isn't my left and right always the same? So what kind of cone? Isosceles. I should put that in a box. So we have isosceles triangle.
That shape's gonna throw me off.
All right. Now let's look at different views of a solid. Number 11. So you're given what the front looks like, what the side looks like, and the top looks like. What you're looking at is the front. This is the front. That's also the front and so on. Okay, let's partner up. Given the following views, can you tell what the actual 3D solid would look like?
Be like Jerome, bro. There's a channel where you
Which one? There's like 20 of them.
Get a lot of
It's like in Rooney.
They don't like Senior night. They're getting.
No, you're gonna be like Matty Ice.
It'll go in and
It's definitely.
I'm a sport.
And here's a side.
Gotta be safe.
It's gotta be sick. You're dumb, Abby. I looked at that
I'm so highly confident at being safe.
It's definitely.
Are they not all the same shape? See, bro.
11 and 12. What did you get?
Let's count together on this one. You guys ready? All right. On the front, I need 1, 2, 3 on the ground. Do I have that? And then I need right above, 1 each stacked up. Do I have that? Above that one, I just want the middle and the right stacked. The middle and the right stacked. And on the very top, 1. And then my side, I need 3 on the bottom. 1, 2, and 3. Is that true? Right above that, I need another 3. And then we have, it looks like it's the same pattern as the front. And then on my top, the top says I better have 3 on the front. Do I have 3? And then it says I need 2 more, but to the right of it. Do I? And then one last one. Boom. So it's got to be A. On example 12, it's a little bit different. It's telling you how many are stacked up. How many cubes are there? So go for it.
So, 4 and 3
Okay, give me a fist. So A is represented by 1, B is 2, and so on, okay? So number 12, the answer is what? A. Represent. There you go. We were supposed to use our hands, but that's okay. Okay, was that it? Yep.